We just finished solving inequalities in a single variable, and so the solution set would be something like x is less than 3, or you could write that as an interval. And when that's the case, because we only have one variable, the solutions are a shaded region of a number line. But if I have both an x and a y, then that adds not just the x-axis, but that's going to add the y-axis to the situation. And so instead of having a number line shaded in, what we'll usually have is an entire portion of the graph that is shaded in, because it's all the possible ordered pairs that make the inequality true. Okay? The solution set to a two-variable inequality is all the possible ordered pairs. So rather than a number line, this is going to be a region in the plane. Similarly, in the number line, we use a solid dot or an open circle to show whether the boundary point is included or not. But in the coordinate plane, since a graph is going to be the boundary, we're either going to use a solid line or a dashed line to show whether we include or not. Okay? So when we graph an inequality in two variables, you're going to graph the function using whatever technique is necessary. If it's a quadratic, deal with that. If it's a line, deal with that. Use a dashed line if it's less than or greater than, a solid line if it's less than or equal to or greater than or equal to. Then the second thing we have to do is we're going to choose an ordered pair on either side of the boundary line. As long as it's not on the line, it can be anything. We're going to plug that into the original inequality to see if it is true or false, because only one side of the graph is going to include the true points. So if the test point I use is true, then I'm going to shade the side that has the test point. If it is false, I'm going to shade the other side. So let's look at two that are lines here. So these two are both linear equations, and so we're going to graph using y equals mx plus b. So the first thing I notice here is this is a less than or equal to, so when I graph this, that's incorrect. Because it's equal to, I'm going to use a solid line when I graph it, okay? And I need my slope, which is 2 over 1, and I need my y-intercept, which is 3. So the first thing I'm going to do is graph my boundary line. A y-intercept at 3, a slope of up 1 over 2 or down 2 backwards 1 to get some more points. And again, we're going to connect this with a solid line. That's my boundary line. That is the line y equals 2x plus 3. So we're either going to shade above or below. I'm going to choose a test point. And zeros are always very easy to plug in, so I'm going to choose to test 0, 0. Now, I cannot pick any numbers that are on the line, because that would only be equal to, it wouldn't show me greater than or less than. So either we're going to shade the side that has the orange point, or we're going to shade the opposite side. So that's what we're deciding. To test this, I'm going to plug it in. Remember, this is an x and a y. And I'm going to plug that into the original equation. So 0 is less than or equal to 2 times 0 plus 3. Is 0 less than or equal to 3? The answer is yes. So that means that this is the true side. So I'm going to shade the graph on the side that has 0, 0. And so that's what it looks like. We have our boundary line and we've shaded the side of the graph. And that's the answer. We can't possibly list all of those out. And the way we would describe them is just with the equation that we started with. So that's all we get. Now on number 2, we are not in slope-intercept form, so we can go ahead and rearrange this equation. So the first thing that I'm going to do is subtract 4x from both sides. That gives me negative 3y is less than negative 4x because I subtracted plus 12. And then I divide by negative 3. But don't forget, when we divide by a negative with an inequality, we have to flip the sign. So this is going to become y is greater than, negative divided by a negative makes this positive 4/3 x, and then minus 4. So our m is 4/3, and our b is -4. Now, before we graph, we always want to check this one is going to be a dotted line because it is less than, not equal to. Okay, so I start at -4, and then I go up 4/3. And again, our line should be a dashed line instead of a solid line. I'm going to again choose to test 0, 0 because it's not on the line. So when I plug in 0, 0, I get 4 times 0 plus 3 times 0, or I guess that's minus, but it doesn't really matter. It's going to be 0 no matter what. Minus is less than 12. So is 0 less than 12? That is again true. So that means we want to shade the side that has 0, 0 in it, which would be this side. Now, here's a shortcut. I will let you in on a little secret. So notice on number 1, the original equation had less than, and we shaded down. But on number 2, the original equation also had less than, and we shaded up. So this is why we have to test a point, because it's not necessarily going to go the way that the sign says. Unless, okay, this is kind of a shortcut to deciding up or down. When y is by itself, so once you have solved the equation for y, I don't know why this W came out funny. When y is by itself greater than shades up and less than shades down. But again, that's only true if you have solved for y. So on number 1, y was already by itself. It says y is less than, so less than shaded down. If we look at the moment where we solved for y up here, once y was by itself, it said y is greater than, and that is why we shaded up. So if you have y by itself, you don't need to use those test points. But if you're not going to get y by itself, then you always want to test a point to decide which side to shade on. Okay, so those are linear inequalities, and you did those in Algebra 1, but this is Algebra 2, and now we're going to talk about quadratic inequalities, okay? So the rule is the same as far as if y is by itself, then you can shade up or down depending on the sign. Dotted line or solid line, same rules. But these are a little trickier to graph. So you might need a little reminder about our quadratic rules and how to get the vertex. So the way we find the vertex, if our quadratic is in standard form, we have to use -b/2a to find the x, then plug it back in to find the y. If it's in vertex form, then remember hk is going to tell us the vertex. We need the vertex and 2 points either to the right or the left that we can then reflect over. So let's look at number 3. I have a is -1, b is -2, c is -1. So when I do x equals the opposite of b, that'll now be +2 over 2 times a, which is -1. So x is -1. And then we want to plug it in. So y will equal the opposite of -1 squared minus 2 times -1 minus 1. And that comes out to 0. So for this one here, our vertex is 1, 0. Oh, sorry, it's -1. -1, 0. Then we just need 2 more points. So -1, 0 is our starting point, and then count up 2 more x's. So 0 and 1. And now we plug those in, and you can just use a calculator to plug them in. The table feature in your graphing calculator is very helpful. So if I plug in 0, I'm going to get -1, and if I plug in 1, I get -4. Before we start drawing, we want to make sure we decide solid line or dotted line, and this one, because it's not equal to, is going to be dotted. It's kind of hard to draw with a parabola, but we can figure it out. So -1, 0 is our vertex. Then we have 0, -1, and 1, -4. And then remember, we just reflect those to the other side. So there's the shape of our parabola, but remember, we have to draw it using a dashed line or a dotted line. So it'll be something like this. And then because it is less than, we want to shade below, which would mean underneath the parabola curve, which would be here. There's our inequality. Number 4 is in vertex form. So remember, h comes from here, but it's the opposite. This is minus h plus k. So our vertex is the opposite of -4, so it'll be +4. And then k, you keep the sign. So 4, -2 is our vertex. Just like before, we'll use that. 4, -2, and then maybe I'll do 5 and 6. This one will have a solid line when we graph it because of the greater than or equal to, and because it's greater than, we should be shading up. So pause your video and take a moment to see if you can graph this one yourself, and come back in just 3 seconds when you are ready to see the work. All right, here's what your graph should look like. We just plugged in 5 and 6 to get those other points and then reflected them over. And then solid line because it's greater than or equal to, and because it is greater than, we're going to shade up again. So that's going to be inside the parabola. Okay? Now, the only extra thing here is a system of inequalities in 2 variables. And all we do differently with a system is we're going to graph them both on the same set of axes, and we're going to find where they overlap, okay? So let's do number 5, and then I will let you look up the last examples on your own with the quadratics. So for a system of inequalities, we're going to have to graph both of these. So I'm going to start with this top one. M is equal to 1, B is equal to 3, and I want a dotted line. So let's graph that. B is 3, up 1 over 1, and I want a dotted line through those points. Since y is by itself, greater than means shade up. Now, you'll notice that I'm being a little bit neater with this one and just using those lines because this is going to get really messy. And so I like to do it that way with those lines so I can see where the lines crisscross. Okay, now the second one is going to be, I'm going to use blue for this one. The second one has a slope of -2, a y-intercept at 4, and this one will be a solid line, okay? So let's graph that. B is +4, slope is down 2 over 1. That's going to be a solid line for our graph. And because this one is less than or equal to, we're going to shade below. So this is why you see where I draw those lines like that, because the section in here where it overlaps is the solution set to this inequality. It's this whole section here where the 2 shaded areas cross. So the only places that I'm going to find solutions are in that double shaded area because it has to be an ordered pair that makes both equations true. Okay? If they are quadratic, it is no different. You just have to graph it with a quadratic instead. So let's just do number 7. Go ahead and see if you can sketch those 2 quadratics, and then we can talk about the shading once you have them graphed. So take a moment, pause your video, and see if you can graph those quadratics. I'll be back in 3. All right, here are my graphs. You can pause the video for a second to check your work before we talk about the shading. Both should be solid lines because they're both equal to inequalities. And so now it's a little easier to tell on mine because they're color-coded. So the top equation is my blue graph. That one is less than, so that one is going to shade underneath the parabola, okay? And then the purple one is greater than, so that's going to shade above. And so you can see the overlapping area is this little round eggy bit in between. And so that is where all of the solutions lie. It could also be anywhere on a solid line, because that would be true for both as long as it is solid. If one of them is dotted, then that cannot count as solutions. So if I said, give me one solution to what is in here, you could pick any ordered pair that is inside the dark shaded region. Okay, that is how we solve systems, and that is it for this unit.